Now this tends to become even more interesting when I do what we always do describing waves, and as I take a second derivative of this. And that means that I want to now talk about a quantum wave function in which I create delta of now I'm going to introduce a new function which is psi of x, y, and z, and I'm also going to begin to include t here sometimes when I feel like it. And this psi is what we had always meant in quantum mechanics as the quantum wave. Nobody has ever explained, well, what is this a quantum wave of or in? Just what is the medium? Is there an ether medium? Just what is waving? What is the physics? What is the material realization of this quantum wave? Nobody's ever answered that question. And yet we have an elaborate quantum theory about description of collisions of particles and every other thing as quantum waves, without really having any understanding of what is the field in which this exists, and I will talk about that more later on. I would like to now just talk about the wave derivatives of this, because when I form this operator, which means again all the spatial derivatives, but now done twice, then it produces these kinds of terms. It means d squared of the wave function psi with respect to x, and again with respect to x, and it's going to add to that derivative of the wave function with respect to x, and also with respect to y, and the second derivative with respect to x, and with respect to z, and finally the one for t. All of these possibilities would come from doing something like this on here and on here. And that's just the first row. There's also going to be another set of these, which are the second derivative of this psi function, but now with y replacing the x's. And two more lines. Finally, operating on the time variable, which we include. So these are the complete array of terms that describe this simple gradient operator taken doubly, and this is frequently now abbreviated as this second degree differential global operator on the quantum wave function. And when we write this equation down in quantum mechanics, then we mean the solution of this enormous equation, separating out all of these terms and asking one by one what do they represent. And that's why these are very complicated mathematics. Nonetheless, I thought some people that are schooled in classical mathematics might like to see this all drawn out in all its beauty.